Here are the derivatives of basic trigonometric functions. The derivative of sine x equals to cosine x. The derivative of cosine x is negative sine x. We are going to use the quotient rule to get the derivatives of all the other trigonometric functions. We will start by evaluating the derivative of tangent x. First, we are going to write tangent x as sine x over cosine x, and now we are going to use the quotient rule. We will apply the quotient rule. Differentiate the top times the bottom minus differentiate the bottom times the top over the bottom function to the power of 2. We are now going to replace the derivative of sine x by cosine x and the derivative of cosine x by negative sine x. And we get that. Now we are going to evaluate this. Cosine x times cosine x, it's cosine to the power of 2 of x. And negative sine x times sine x, it's plus sine to the power of 2x. Now we are going to use a very famous Pythagorean identity. Cosine to the power of 2x plus sine to the power of 2x equals 1. We get that. But this can be written as 1 over cosine x to the power of 2. 1 over cosine x is secant x, and we get secant to the power of 2x. We conclude that d dx of tangent x equals secant x to the power of 2. Now we are going to differentiate the cotangent function. Again, we are going to write it as cosine x over sine x, and we are going to apply the quotient rule. We get that. Now we are going again to replace the derivative of cosine x by negative sine x and the derivative of sine x by cosine x. And we get that. This is almost like before, but if you can see now we have negative sine to the power of 2x, negative cosine to the power of 2x, but I can distribute negative 1, and I get that. And using exactly the same Pythagorean identity as before, I get that this is negative 1 over sine to the power of 2 of x. This can be written as this, and we get negative cosecant to the power of 2 of x. We conclude that d dx of cotangent x is negative cosecant to the power of 2 of x. D dx of secant x, we are going to write secant x as 1 over cosine x, and as usual we're going to apply the quotient rule. Be careful! The derivative of 1 is 0, so we get that. Which is this. It is customary to actually write that. We will write it first as sine x over cosine x times cosine x. Now we have sine x over cosine x times 1 over cosine x. The first one is tangent x and the second one is secant x. If you look at the book or in all places, you will see that it's going to be written that d dx of secant x is tangent x times secant x. Again, because of the flexibility of trigonometric functions, you may differentiate a trigonometric function and you get something that it's not exactly what is in the answer key or in the book, because there are many ways to express these functions. And in this case, we have to differentiate the cosecant of x, which is 1 over sine x. We are going really quickly to apply again the quotient rule. Don't forget that the derivative of 1 is 0. We get that. But again, if you look at the charts, you will see that this is not exactly written that way because, as before, we are going to write it like this and we're going to split it into two functions. Now we get negative of cotangent x times cosecant of x. And we conclude that d dx of cosecant of x is negative cotangent x times cosecant of x. So here are the derivative of trigonometric functions other than the cosine and the sine, as we did already. Example: differentiate the function f(x) equals sine of 2x using the identity sine 2x equals 2 sine x times cosine x. For the 2, we can use the constant rule, and then we will use the product rule for the product of sine x with cosine x. We differentiate the first times the second plus differentiate the second times the first. d dx of sine x is cosine x, and d dx of cosine x is negative sine x. We get that. Now I would like to recall that cosine to the power of 2 of x minus sine to the power of 2 of x is cosine 2x. And we get 2 times cosine 2x.